Hi everyone. So this video is meant to kind of walk you through this quiz review for the Quadratics chapter. This is chapter 6. And so far in this chapter we've covered some FOIL, we've covered how to simplify, we've covered solving, which remember is very different than simplifying. We've talked about some different types of word problems, and probably most importantly, we've talked about vertex form and translations. Okay, so that's kind of what's covered here in this review. This video will cover just the front page of the review, and then I'll do a second video for the back. Okay, so these first two are both talking about simplifying. Whoops, ignore that. Simplify, expand and simplify just means we're going to write it out with the square. Either way, these two are going to be FOIL problems. Okay, so here, x times negative 3x is going to be negative 3x squared. Just don't forget your square there. X times negative 2 is negative 2x. 4 times negative 3x is negative 12x. And then last but not least, 4 times negative 2 is negative 8. When I go to write my final answer, I'm going to put those two things together. So I end up with negative 3x squared minus 14x minus 8. That's the final answer there. Okay, so number 2, I have to figure out what to do with that square, which is where this expand thing comes in. Expand means I'm going to have to write this out twice. So what is this? 5m minus 6 times 5m minus 6. And now I'm going to FOIL those. So 5m times 5m. 5 times 5 is 25. And m times m is m squared. And then I'm going to get a minus 30m and another minus 30m. And then negative 6 and negative 6 is positive 36. And then I'll put my middles together, and I end up with 25m squared minus 60m plus 36. Okay, 3, 4, and 5 look sort of similar to these problems, like when you look at the actual equation that you're given, but notice that these directions say solve, okay? Solve means that in your final answer, you're going to be able to say what x equals, or I guess in this case, what g equals. But either way, the big point I want to make here is when it says solve, you are not going to FOIL, okay? Because foiling is spreading the mess around. Foiling makes everything look pretty and it takes it all apart and writes it out nice, but it doesn't actually get anything by itself, okay? If we want to get this stuff by itself, if we want to get g by itself, we have to dig it out of there. So I would start by subtracting 10 here. I'm going to kind of write this over here. So that gives me g plus 1 squared equals negative 100. And then I want to think about, I'm not foiling, do not FOIL. I'm thinking about how can I get, because I want to be able to take this 1 away, but I can't do it while it's trapped inside those parentheses. I need to get rid of that square somehow. So I would take a square root here. The problem is right here, I can't take a square root of a negative number. So as soon as I'm at that point, I can say there's no solution to this one. There's no number that I could plug in for g here and have this work out. Okay? Now let's look at the next one. The startup is very similar. I'm going to subtract 10 and subtract 10. So I end up with g plus 1 squared equals positive 100 this time. So this time I can go ahead and take a square root. When I take a square root, right away I know I'm going to have two different answers or two different problems. On the left side, square root of g plus 1 squared, all that's really happening there is those two things are canceling out. So I know I'm going to end up with g plus 1 either way. Okay, but then square root of 100 could be 10 or it could be negative 10. Okay, and then I'm going to solve each of those separately just by subtracting 1. So here's g equals 9, and this would be g equals negative 11, and that's what my answer would look like. g equals 9, or g equals negative 11. Okay? Okay, so on number 5, I would subtract 3. Okay, minus 3 minus 3. So I end up with 5x squared equals 5. Now, I've seen a lot of people want to take a square root right now. We're not ready to take a square root yet because the squared part is not by itself. We have to get rid of that 5 first, and I'm going to do that by dividing by 5. Divide by 5. And that leaves me with x squared equal to 1. I'll run them together here. Take a square root, and then remember you're going to get two different answers. So x could equal 1 or x could equal negative 1. Okay, so again, I cannot emphasize this enough. When you're solving, do not FOIL at this stage of the game. Okay, I know it looks like FOIL, it feels like a problem where you should do FOIL, but you're not going to be able to solve it right now if you do FOIL. Eventually, once we learn quadratic formula, you would be able to. Okay, looking at number 6, we've got two pieces of paper with the same area. We have a rectangular piece that is 7 by 13, and we have a square piece, and I don't know what the side lengths on that are, but that's what I'm trying to find. Okay, so I'm going to call that x, and because it's a square, I know that all of my sides are x. And I know that the areas are the same, right? They have exactly the same area. So my general strategy here is I'm going to find the area of this one, I'm going to find the area of this one, and I'm going to make them equal each other, okay? And once I make them equal each other, then I should be able to solve for what x is. So for this one, my area would just be 7 times 13, which is 91. For this one, my area would be x times x, which is x squared. And so now I can say, I know that these two things have to equal each other. So let's say x squared equals 91. Take a square root, take a square root. Now normally right here when I take a square root, I would need two different answers, okay? But because this is talking about the length of the side of a square, the negative answer really doesn't make a whole lot of sense. So I'm just going to take the positive answer, and I'm actually just going to believe all the people I've seen do this problem today. I believe this answer comes out to be about 9.5, okay? But that's it for that one. Once you get this piece set up, you should be good to go. Okay, our favorite painting question or picture or whatever it is. We've got a painting that is 5 by 7 with a frame or a mat around the outside that is W inches long all the way around. Okay. I want an expression for the area of the whole thing. So I want this entire area, the whole thing. Well, this is just a rectangle, right? And so I can get area by just doing length times width. And my length is just going to be the 7 inches plus a W plus a W. So that's going to be 7 plus 2W. Up the side, I'm going to have 5 plus a W plus a W. So that's going to be 5 plus 2W. And then I'm going to FOIL those two things together. Okay, oh, didn't realize my paper was going sideways. I do have to FOIL it because it says that it wants my answer simplified. Okay, so I'm going to go 7 times 5 is 35. 7 times 2W is 14W. 2W times 5 is 10W. And 2W times 2W is 4W squared. I'm going to go ahead and write my answer with the squared term first. We're starting to talk about standard form now, and standard form always has the square in front. If you didn't put the square in front, that's okay as long as your answer is simplified. So it'd be 4W squared. I can put these together and make it 24W, and then plus 35. Okay. And one more quick one, number 8. if I want the area of the shaded region, okay, the shaded is kind of everything on the outside here, not including this middle part. In general, this is what my strategy is going to look like. I'm going to take the area of the outer rectangle and subtract the area of the inner rectangle. Now, I saw a lot of people today kind of calculating these two things separately and then trying to go back and subtract them. That's totally fine, except that I will tell you I see a lot of people make mistakes with the subtraction when they do it that way. I would probably set it up all in one expression, and then I'll show you how to deal with it from there. So the area of my outer rectangle is going to be these two guys. So 4x minus 3 times 7x plus 5. Okay? Minus, now this is what I'm talking about, is a lot of people would go off to the side and kind of calculate the area here separately. I would just keep writing. So my area for the inner rectangle would be the 2x times the x plus 6. Notice I'm putting the 2x first. That's because it's just a single term. So when I go to multiply it, I'm not really foiling it, I'm just distributing it. And distributing it is easier when it's out front, or at least it's more recognizable. Okay, so here I'm going to go 4x times 7x is 28x squared. All right, 4x times 5 is 20x. Negative 3 times 7x is negative 21x. And negative 3 times 5 is negative 15. Now, the reason I said the thing about the subtraction is right here, if I just treat this like a negative 2x when I distribute, I don't have to worry about that negative sign coming back to haunt me. So I'm going to go negative 2x times x, and that's negative 2x squared. And then I'm also going to do negative 2x times 6 and get negative 12x. Now, if you were just doing this area separately, this would have come out to be a positive 12x, but then you would have had to remember that you're subtracting it. So just be careful there. That's why I included the negative with the 2x sign. Okay? Now that I've got all of that written out, I can go through and just combine all my like terms. So 28x squared minus 2x squared is 26x squared. 20x minus 21x minus 12x. So 20 minus 21 is negative 1, and negative 1 minus 12 is negative 13x. And then I just have a minus 15 here. And that right there is what goes down for my final answer, and it's just an expression. Okay? Okay. I'll go ahead and leave that shot there for a minute so that you can catch up on all of that if you're having trouble. Or if you did it yourself, I would go back through and see if you can identify where you made a mistake. If I had to guess, I would guess it was in when you did the 2x times the 6 and got 12x, remembering that you were actually subtracting that 12x, not adding it. Okay, so if you got everything right except for this term, that's the first place I would check. Okay, I'm going to go ahead and do a second video for the back side of this page. So that's it for this one, but if you want to check out the back side, I'll have that posted shortly.